Hello, my name is Christopher. I'm a research software engineer with Research Software Workshops, and it's a very warm welcome to Introduction to Data Analysis in our Part 3. So the link to the course material is here at the bottom, and that should bring you to this page, which is basically the section on reading from files. Now, you'll have an RStudio open, and what we're going to do is we're going to first create a new R notebook. So we'll do File, New, R notebook, and I'm going to call this, let's get rid of this sort of boilerplate, and I'm going to save this as files.r markdown notebook. Okay, so one of those common situations when you're doing data analysis is that you have some data file that contains the data you actually want to read. Now, perhaps this is data you've produced yourself, or maybe it's from a colleague or from a sensor. There'll be some data somewhere that you need to load into R to basically do some analysis. Now, in an ideal world, that file will be perfectly formatted and it'll be so trivially easy to import into R, and the data will be clean and everything will be wonderful. But unfortunately, in the real world, this is often not the case. Now, R provides a number of features to make your life easier so that you can clean up the data and import it into R so you can then work on it. Now, full information on reading and writing data is available in the book R for Data Science, which I encourage you to read. But first, it's worth noting that the common formats that R can work with include things like comma-separated tables or tab-separated, colon-separated, space-separated, etc., Excel spreadsheets, HDF files, SQL databases, etc. So R can read data in from lots of sources, and I do encourage you to read the online book to see how you can sort of connect up to those other data sources. Now, for this particular workshop, we will focus just on plain text files. So what I'm sort of calling comma-separated value files, but you'll see they're not really comma-separated value files as we move forwards, as these kind of like basic text files are perhaps the most common format. So let's imagine that we have a text file that looks something like this here. So this is what we need to load in. This contains the data, and you may recognize this as being effectively very similar to the population data that we were looking at in the last section. Now, this file is basically linked to from this link, citypop.csv, and if I click on it, you can see here is the raw file. And indeed, what I'm going to do is I'm going to copy the URL for that. So I've got it into my clipboard. Now, we can use the tidyverse's readCSV function to read this data and convert it into a tibble. Now, readCSV is part of the reader package and is installed with the tidyverse. So the first thing I'm going to do, obviously, is load the tidyverse up. Okay, it's now loaded. And then if I put into here question mark read CSV and then run, this will get the help for this function. You can see here we are, it's popped up, and it will say how we can then use this to be reading files. Now, the first argument is file, and that is the location. Indeed, if I look down here, we can see the documentation for file. Where are we? It's enter the path to a file, a connection, a literal data or raw string. And indeed, look, you can even read in compressed files, and it will automatically download files from websites as well. So this means we can directly use the URL of that web page that contained the CSV file. So I'm going to now in here say that the citypop file that we want to load is going to be assigned, or the actual file itself is going to be this URL, so that's where it comes from. And I'm now going to do read CSV citypop file to see what happens. And generally I recommend the first time you try and read the file, just read it up directly. This is going to be quite an interactive process. So it's going to have a go, and you can see this is what is loaded, and you can see, this doesn't look good. It's 1 column and 11 rows. That hasn't done a very good job of separating this data into columns. Now, why is that? Well, the first thing is, I was calling this a comma-separated file, but of course these aren't commas that separate it, these are semicolons, and so it's no wonder actually that readCSV did quite a poor job at this. The other reason is, look, there's like 5 lines here of like stuff at the top, which is just, for humans to read. It's not really for the computer to have to parse. So the first thing I can do, let's try again in a new R block so that we can distinguish things out. Let's say read CSV Well, let's fix the first problem first. So we're going to load city-pop file. And what we're going to do now is we're going to say, let's skip, because skip, if we look down here, let's see, is there a skip item? There we are. Skip is the argument we use to skip the number of lines before reading the data. So we can say skip equals 5. And that should mean skip the first 5 lines. Oh, and I forgot my comma there. There we are. So okay, that's done a good job of getting us the column names, and we've lost that initial bit of data. But again, we haven't dealt with the problem that this is a semicolon separated file rather than a comma separated file. Now, one thing you may have noticed when you looked in the help is actually we're talking about reading delimited files, and you can see that we have this thing that's called read_delim. Read_delim is how we can specify, it's the function we use for any kind of delimiter. So if we change read CSV to read_delim, and then when you look, read_delim actually has here, let's have a go down through this, a delim argument, which is required as the second argument. And you can see that the delim argument basically is a single character used to separate the fields within the record. And in this case, the delim, which we're going to put in, is equal to a semicolon. Okay, let's now try and read it with this. Okay, this is looking a bit better. We now have the year, city, etc. set out, but still not perfect. It's beginning to look like a table of data, but it's not totally perfect. We have these little like missing bits here, and you know, everything is read as doubles. So you can see DBL, even the year, which really should be an integer, has been loaded as a double. Equally, some of these values have things where we have a -1 in, well, the population couldn't possibly be -1, kind of negative people, and so this must mean that this is where the data was not available. Now in some places it's recognized data not available and used NA for not available, but we need to tell R that -1 is also a not available value. Now we can do that by passing in the NA argument, and NA is where we can specify things that are not a number, or not available, in this case -1. Okay, so now we have the -1s gone, we can see we've got our NA values. And as I said, the next problem is that the year has been read in using a double argument. Now in Reader, each column is read in using a parser that converts the text data into the file into the data of the appropriate type. And R is going to guess which parser to use. And this is helpfully reported to the R console. So if I look at the R console now, we can see that it read it in with year was read in using col double, city was read in using col double, or London was read in as col double, Paris col double, Rome col double for the populations. Now R will always try and guess which one it wants to use unless you specify it exactly. And so col double was used, and so the function parse double, which is how it parses text into doubles, was the function that was then used to create the numbers. Now the tidyverse supplies many parsers, for example parse integer, parse date, etc. And there's more detail about these parsers, including how to parse different date formats, different number formats, can be found in the free online book R for Data Science. Now you can set the parser to use for a column by specifying the column types via the col types argument. So if we put this in here, col types, this is where we can say which columns should have what. We use cols, so we can then specify which columns we will be working with. And in this case, I'm going to say the year is going to be parsed in as an integer, so col integer. Now when I run, we can now see we've loaded up the year as an integer. And col guess is the default. So col integer means as an integer, col guess is the default, and that's where it guesses that it's going to be a double or a string or whatever. Now finally, we've just read this, we do want to assign this data to a variable, so we're going to assign this to a variable called census, and then just clean things up a bit, just make this look a little bit cleaner. A little bit of white space in here just to make these things sort of look nicer. And there we are, we've now read in the data, and it's been placed into the variable called census. And we can check the value of the variable census, just here. Excellent. So all this has done is we've now walked all the way through this particular section of the workshop notes. And at the bottom of the notes, you'll see here we have an exercise. Now you can see there is a file, which is this URL, which contains some data. So if we just take a look at this, you can see this is some temperature data from a site in England. Now what we need to do is we want to load this data into a tibble. Now this data was originally from the Met Office and there is a description of the format there too. Now this contains some historical weather data for a location in the UK. Now you're going to need to import this file as a tibble using the function read table. So not read delim, read table. That's how we read data in, which is space separated, as you can see here. Now, load it up using read table. Have a look at the help for a read table to see how you should do it. And then make sure you cover all of the possible NA values for sort of values which are wrong values within this data so it's cleaned up. Once you've loaded the data into a tibble, I'd like you to answer how many years had a negative average temperature in January, and then what was the average temperature in June over the years in the data set. Press pause and have a go at this exercise, and then when you come back from pause, I will show you the answer. Okay, you've now come back from pause, so I'm ready to show you the answer. So let's start off here with an empty sort of R notebook. First thing we're going to do is load up the tidyverse, so library, tidyverse, in R. Now, as I said, you can only use the read table function because read delim will read files when you have single sort of delimiters. When we have a table with lots of spaces separating it, if you try to use read delim with a single space, it would have problems because there are different numbers of spaces between these different columns. So we need to use read table. So the first thing we're going to do is just have a look at read table. Always get that the wrong way around. There are question mark read table just to pop up the help here, and you can say this is how we read textual data where the column is separated by one or more columns of space. Indeed, it's very similar to read delim in that we have the file and we also have things like skip and NA and col types, etc. So let us now do temperature as being the variable which will hold everything, and that's going to read table from the URL first. So let's take this URL. And then we now need to work out how many rows to skip. Let's have a look. Let's count them up. So 1, 2, 3, 4, 5, 6. So let's skip 6 rows. And then have a look and see what this has done so far. So temperature. So always build these things up bit by bit. Okay, it's loaded it up. It looks like we have the right columns here. But notice how everything has been loaded up using doubles, which is fine for all of this month data, but it's the wrong data type for the date. So let's maybe set the data type as an integer. So we'll do col types equals cols date is going to be equal to a col integer. Okay, let's see what this gives us. Okay, our date's an integer. The rest of the months are now doubles. This is all looking pretty good. So if we scroll through, does anything look like it's a miss? Well, as we look through, let's see here at the end, do we see at this point that in 2020 we're missing data from August onwards, and that's represented in the data as this minus 99.9, and indeed look, we're also using minus 99.99. So these are wrong values, they're missing data, and the person collecting the data has used this to signify something's wrong. Now obviously that could be confusing if we're calculating averages or things, so we must make sure that we specify these values as being NA values. And we can do that by saying NA values are equal to, we can put in multiple NA values here, so let's do minus 99.99 and also minus 99.9. Okay, so if I now reload this, rerun it, let's have a look at those last columns. Yep, there you are. You can now see all of these non-existent data are now set as NAs, and you can see they're not non-existent because this is actually the data for 2020, and the last collection for this particular data set was in July, so nothing was available after July 2020. Now the question we now have to answer is how many years had a negative average temperature in January. So let's do the first thing. So we want now to say how many years had a negative average temperature in January. So first thing I'm going to do is let's find all the years that have a negative January. We can assign that by filtering this our temperature table through a filter where we say that the temperature in January must be less than 0. And then let's have a look at what negative Jan gives us. So this here you can see all of the years now, all of the values where we have a negative January. Now what we want to do is say how many years have a negative value have a negative temperature in January, and we can do that by counting them up. So if we say the number of negative Januaries is going to be assigned from as numeric, because we want this as a number, the count of the number of rows in negative Jan. So count will count it all up, and then as numeric will then turn that back into a number. There we are, we have 20 years, which gave us a negative, had a negative January. Indeed, I can print those out so we can just double check that's the right answer. Here we are. We have 20 rows as it says, matching the 20 years, where the temperature on average was negative in January. Now the next question was what was the average temperature in June over the years in the data set? Well, we can get this by using the mean function. So the June average is going to be equal to, so let's put that into a variable called June average, and that's going to be the mean of the values in the June column. And remember, we want the actual values themselves, so we use square brackets. Print that to the screen and let's see what we get. There we are. The mean June temperature across this entire data set was 14.3 degrees. And again, notice we've had to use the square brackets because we want the actual data. I think if we try this without the square brackets, we won't get the right answer. There we are, the argument is not numeric. So that's why we need to actually get the actual data itself. Okay, so that's the end of this exercise, and that's now brought us to the end of this particular section. And this covers the basics of reading data with R. Now, as I said, there are excellent online resources which will let you go into more depth for your particular data set, and I do recommend you read the excellent online free book, R for Data Science, and also check out the documentation for Reader or the really handy official Reader cheat sheet. So that's now the end of this part. Welcome you back onto part 4 of the workshop in the next video.